In this video, we will learn a fun rule of checking the congruency of two right-angled triangles. Suppose we have to make a triangle ABC whose one angle, like B, is a right angle. Will we be able to construct a unique triangle from this information? Give it a thought. From this information, we can make different types of triangles which are not the same size. That is, the information given is insufficient. With this, if you are given a measurement of an arm forming the right angle, such as BC is equal to 6 cm, will you be able to construct a unique triangle? In this case also, we will get different types of triangles. Now suppose you are given the measurement of the side and the hypotenuse of a right-angled arm. Will you now be able to construct a unique triangle? Pause the video and create triangle ABC, which has angle B is equal to 90 degree, BC is equal to 6 cm, and AC is equal to 10 cm. Let us tell you. For this, we will draw a line segment BC, which is 6 cm in length. Then we will draw a right angle from point B to BC with the help of a protractor. A will be positioned on this ray. Can you tell how we will find the position of A? Give it a thought. Absolutely right. Since here AC is equal to 10 cm, we will open the compass 10 cm, place its pointed end on C, and draw an arc cutting this ray. Intersection of arc and ray is the vertex of triangle ABC, that is, A. We will complete the construction of right-angled ABC by connecting A to C. Can you make different types of triangle ABC from given measurements of different sizes? Try pausing the video. You will get equal-sized triangles in each case. That is, you will get congruent triangles. From this, we know that if the measurement of a side and hypotenuse of a right triangle is given, then a unique triangle is formed. With this understanding, we can get another rule for checking congruency of triangles. Can you tell me what will it be? Give it a thought. Come on. Absolutely right. If under a congruence, the hypotenuse and one arm of a right-angled triangle are equal to the hypotenuse and one arm of another right-angled triangle respectively, then those triangles are congruent. For example, here are two right-angled triangles, triangle PQR and triangle LMN, with angle Q is equal to angle M is equal to 90 degrees. The side being PQ is equal to LM is equal to 5 cm and the hypotenuse PR is equal to LN is equal to 13 cm. If one of these triangles is placed on the other, then we will be able to see that it completely covers the other triangle. That is, both of them have equal size and shape. In geometry, we say that triangle PQR and triangle LMN are congruent. Here the congruency is as such that it tells us that PQR is congruent to LMN. Therefore, the relation of congruency can be written as triangle PQR is congruent to triangle LMN. Now let's talk about triangle PQR and triangle EFG. Among these, angle Q is equal to angle F is equal to 90 degrees. The side PQ is equal to EF is equal to 5 cm. but the hypotenuse of triangle PQR is 13 centimeter, while the hypotenuse EG of triangle EFG is 15 centimeter. If one of these triangles is placed on the other, then we will see that one triangle cannot completely cover the other triangle. That is, the size and shape of these two are not equal. Therefore, in this case, triangle PQR and triangle EFG are not congruent. So now you must have understood that with RHS congruency theorem, you can check the congruency of any two right-angled triangles. Today we learned the RHS theorem of congruency of triangles. RHS theorem of congruency of triangles. Example 1. Observe the following figure and find out whether triangle ADB and triangle BDC are congruent. If it is, write their congruence relation. We must use one of the theorems, that is SSS, SAS, ASA or RHS to test the congruency. Can you tell which theorem would be correct to use here? Give it a thought. Let us tell you. For this, we will first understand the given information. In the given figure, both triangle ADB and triangle BDC are right-angled triangles, in which we are given angle ADB is equal to angle CBD is equal to 90 degrees. At the same time, we have also been given that hypotenuse AB of triangle ADB and the hypotenuse CD of triangle BDC both measures 7 centimeters. That is, AB is equal to CD. Do you realize anything else by looking at the given figure? Give it a thought. Absolutely correct. The side BD in both these triangles is common. That is, BD is equal to BD shows us that the hypotenuse of these two right-angled triangles is equal and one arm is equal. So here we can say that triangle ADB and triangle BDC are congruent with the RHS theorem. So, let us symbolically write the relation of their congruence. Can we write this as triangle ADB is congruent to triangle BDC? Give it a thought. Absolutely right. We cannot write it like this. In order to be properly indicated in a symbolic way, we have to understand the relation of congruency. Here, angle ADB is equal to angle CBD is equal to 90 degrees. In this way, we can say that the vertex D corresponds vertex B. Here, AB is equal to CD. And at first, we concluded that the head of vertex D is corresponding to B. Hence, we can say that the vertex A corresponds the vertex C. Similarly, we can represent that vertex B corresponds vertex D. In short, we can say that DAB corresponds to BCD. With the help of these, it can be said that triangle DAB is congruent to triangle BCD. Keeping in mind the relations, we can also show the congruency of these two triangles in the following way. Next example. In the following figure, if AB is equal to BC, YB is equal to BZ. So, with the help of RHS congruency theorem, verify that angle Y is equal to angle Z by looking at the given figure and reading the question properly. we get the following information. Triangle YAB and triangle BCZ are two right-angled triangles. In the question, we are given that sides YB is equal to side BZ and the side AB is equal to side BC. We know that the concept of the RHS congruency theorem is that if, under a congruence, the hypotenuse of a right-angled triangle and one side are equal to the hypotenuse and one side of another right-angled triangle, respectively, then those triangles are congruent. From this, we can say that triangle YAB and triangle BCZ are congruent under RHS congruency theorem. Here, vertex Y is corresponding to the vertex Z. Vertex A is corresponding to the vertex C. Vertex B corresponds the vertex B. That is, YAB corresponds ZCB. So, we can say that triangle YAB is congruent to triangle ZCB. Note that triangle ZCB and triangle BCZ are the same triangle. You will remember that we can write the names of any polygon in different ways. Because vertex Y is corresponding to vertex Z, we can say that angle Y and angle Z are corresponding angles. Since the corresponding parts of a congruent triangle are equal, therefore, we can say that angle Y is equal to angle Z. If we trace this shape on the trace paper and fold it on its width in such a way that the fold passes through point B, that is, place triangle YAB on triangle BCZ, then we can see that angle Y fully covers angle Z, verifying that the measurements of both triangles are equal. Find out which triangles are congruent by looking at the measurements of the parts of the triangles given below. Discuss your answer with your friends or your teacher. Today we saw some interesting examples related to the RHS theorem of congruency of triangles. Misconception 1. In the figure shown below, which theorem of congruence can prove that triangle ABC is congruent to triangle PQR? Some children have the misconception that only the RHS theorem can be used to check congruency of right-angled triangles, and none other can be used. In both the triangles, the right angle are equal. One arm is equal to the corresponding arm of other triangle, and also the hypotenuse is equal. Observing that the RHS theorem is being used here, with this understanding, they choose option 2 as the answer, but it is an incorrect answer. Because here, all the three sides of triangle ABC are equal to the three corresponding sides of triangle PQR. Here, we can also use the SSS theorem. Therefore, the correct answer here is option 3. Some children choose option 1 in haste just by looking at the arms, but this is also an incorrect answer to the given question. Misconception 2. Find out whether triangle ABC and triangle LMN are congruent or not. Some children are aware of the RHS theorem but are unable to use it properly. Like here in triangle ABC and triangle LMN, we see that angle C is equal to angle L is equal to 90 degrees. AC is equal to LM is equal to 6 centimeter. And AB is equal to LN is equal to 10 centimeter. Realizing that both triangles are right-angled triangles and their two sides are equal, they assume that both triangles are congruent under the RHS theorem, and from this understanding they select option 1. But it is a wrong answer. Children do not read the given information properly. In triangle ABC, the right angle is at the vertex C. So, AC is the side of triangle ABC and AB is the hypotenuse of triangle ABC. You can find it out by making a rough diagram. Similarly, in triangle LMN, the right angle is forming at the vertex L. So we can say that both LM and LN are the sides of the triangle LMN and MN is the hypotenuse of this triangle. Here we do not know the measurement of a hypotenuse. We can find it with the help of Pythagoras theorem. Find out how this is done yourself. On finding this, we see that the measurement of one arm in both the triangles is the same, but the measurement of the hypotenuse is not equal. So using the RHS theorem here, we can say that these two triangles are not congruent. Therefore, option 2 is the correct answer. So today we saw some misconceptions related to RHS theorem of congruency